Good afternoon everyone and welcome to my YouTube channel. So here today we are going to be looking at Dalton's laws. We are going to look at the conservation of mass, we are going to look at his definite proportion and the multiple proportion. So firstly, let's begin with our conservation of mass. What does it say? The total mass in a chemical reaction remains constant. So now, what we mean by that is that the sum of the mass of the reactants is equal to the sum of the mass of the products. So this is what we mean. So in other words, we can define the law of conservation of mass as mass is neither created or destroyed. So that's the way it is. So now, let me now clarify what I mean by this. So mass is neither created nor destroyed. So if you look at this, we have a balance. So this balance is very, very important in such a way that if this is mass, you will find that the beam will be balanced. Now, why is the beam balanced? Because the mass of the reactants is equal to the mass of the products. So that is what we call the law of conservation of mass. Let's clarify it with an equation. Let's take this example. So if we have this equation, balance, so the mass of hydrogen, it will be this 2 times the 2 that is here times the molar mass of hydrogen, which is 1.01. Then we have oxygen, we have plus our 2 times the molar mass of oxygen is 16. So we are going to have our 2 times the molar mass of water is such that we are going to have 2 times 1.01. Then we have plus, so this 2 times 1.01. Then we have plus our 16 like that. So we are going to have 2 times 2 is 4 times 1.01. That will give us a 4.04. We add plus our 32 there. So this is the mass of the reactants, which will be equal to a 36.04 grams. So this is the mass of the reactants. Now this side we have a 2 times our 2 times 1.01. This will give us a 2.02. Then we have plus our 16. This will give us a value that is equivalent to 2 plus when we add this, we are going to get 18.02 like that. Then when we multiply 18.02, this will still give us a 36.04 grams. So as you can see, the mass of the reactants is our 36.04. So is the mass of the product. So therefore, we can conclude, according to Dalton's atomic theory, that the mass of the reactants is equal to the mass of the product. So the mass is neither created nor destroyed in a chemical reaction. Let's look at our next law. The law of definite proportion, on the other hand, talks about how a certain compound has got a fixed proportion by mass. So it states a pure substance, no matter its source, always has got a fixed proportion or definite proportion by mass. So just as we have said, a pure substance, no matter, so it has to be a pure substance, no matter its source, always has got or contains a definite or fixed proportion of the element by mass. So what we simply mean by this is that if you're looking at water, which is your H2O, 2 parts will be for hydrogen. So in water, we shall always have hydrogen in 2 parts, no matter its source, as long as you are looking at a pure substance, then it shall have a fixed proportion by mass like that. So 2 parts will be for hydrogen and 1 part is for oxygen. In other words, the hydrogen will always have a mass that is equivalent to, since there are 2 electrons in hydrogen, you shall say 2 times 1.01, then you shall get a 2.02. Then oxygen, it shall be 16. grams. So the percentage by mass is the same in water, no matter its source, as long as it's a pure substance. So for this one, so the elements of the compound are always present in the same proportion. So if we have, let's say, 4 hydrogens and 2 oxygens, you will find that 2 hydrogens shall be bonded to 1 oxygen. So it's a fixed. We have H2O here, 2 parts hydrogen, 1 part oxygen. Even here, we shall have H2O. So since there is a fixed ratio of a 2 to 1, that is what we refer to as the law of definite proportion. So in other words, we can say the elements of a compound are always present in the same proportions by mass, like that. So that is the law of definite proportion. Let's look at our last law, which is the law of multiple proportion. The law of multiple proportion simply states that for 2 or more compounds composed of the same elements for a given mass, any one of the elements, the ratio of the masses of any other element in a compound is a simple or a small whole number ratio. Let me explain that. So this is one of the longest laws. So now let me clarify it. So the law of multiple proportion, just as I have said, is states that for 2 or more compounds composed of the same elements for a given mass of one of the elements, the ratio of the mass or the masses of any other elements is a simple whole number ratio. Let's explain this. So now let's take a simple example where carbon reacts with oxygen. So there's a possibility that we might form carbon monoxide. Let me begin with carbon dioxide due to space. Then there is also a possibility that the compounds that can be produced is carbon monoxide. So that is the law of multiple proportion. Now in this case, for some mass such as carbon, which is just constant, which is our 12 there, now it depends with how many parts of oxygen reacts with the carbon. If it is 1 part, the ratio will be such that then the oxygen is 16. In here, carbon is 12. Oxygen here, 2 times our 16 is our 32. So now according to that, we have the mass, it is a 12 to 16. Now the combining ratio is 1 carbon combining with 1 oxygen. Here we have 1 carbon reacting with 2 oxygens. Now the law of multiple proportion can be proved by looking at the masses. If you look at the mass of oxygen and carbon monoxide, it's 16. Then the mass of oxygen and carbon dioxide is a 32. So when you find the ratio there, it will give you a 1 to 2. So this is the law of multiple proportion. So let us review on that. So when 2 or more compounds composed of the same elements, so these in our example might be the carbon monoxide and the carbon dioxide, for a given mass of any of the elements, so we might have the oxygen there, the ratio of the mass of any other elements is a simple whole number ratio. Even if we were to compare carbon, we could have just found a 12 to 12, which will be 12 to 12 will just be a 1 to 1 ratio. So those are the laws of Dalton's which it deduced. Thank you very much for watching. Hope you would like, subscribe, and share for more. See you in the next tutorial.